All right, welcome back, guys. So now we're going to be doing another incline block problem. However, this is going to be an incline block problem with a pulley and also a problem that takes friction into account, okay? So here's the scenario. We have two masses that are connected by a rope on a frictionless pulley of negligible mass, okay? So one of these masses is essentially hanging off the side of the ramp, and one of them is sitting on the ramp. And now the question is asking, do the blocks move? And if so, in what direction and with what acceleration? Okay, so in this scenario, we're basically going to have to compare the force due to gravity on this block and the force due to gravity on this block to first determine if we didn't have friction, in which direction would the blocks travel. And then once we know that, because we know friction opposes motion, we'll then know in which direction friction travels, and then we can then see if the blocks move at all. So first let's draw a free body diagram of the 30 kilogram mass. So we have the normal force, which is acting perpendicular to the ramp. We have the force of gravity acting down. And like last time, we're going to break gravity down into its components. And we know that this angle here is equal to the angle of inclination of the ramp. So it's going to be 35 degrees. And we know that these two sides, the component of gravity and the normal force, are equal. So this component of gravity is essentially the normal force. So we're now going to solve for the two components of gravity. So we know this component of gravity is going to be the mass of the block times gravity, or mg. That's essentially this side, times the cosine of theta, which is 35 degrees. And from that, we get roughly 240.83 newtons. So we know that the component of gravity, which is perpendicular to the ramp, or therefore the normal force, is 240.83 newtons. So now we want to find the component that is actually causing movement down the ramp, this one right here. And that is going to be the hypotenuse, which is mg, sine of theta, which is 35 degrees. And from that, we get roughly 168.63 newtons. So now, this is the force due to gravity that is causing this block to want to slide down the ramp. So because these blocks are connected, we now have to compare it to the force of gravity on the second block that wants to cause it to fall. And from there, we can determine, without friction, which way the block should travel. So the force of gravity that's making this block want to fall is just going to be the mass of that block times gravity, which is going to be 10 kilograms times 9.8. Or in other words, we're going to get 98 newtons. So we have 168.63 newton force that makes these blocks want to move like this. And we have a 98 newton force that makes these blocks want to move like this. So if we subtract them, we get a roughly 65 newton force, which is going to be the net force, which is going to want to make this block slide down the ramp and pull this block up with it. So basically we know now that the parallel force of gravity on this block is greater than the force of gravity on this block. So if we didn't have any friction, this block would pull the other one up with it as it slid down the ramp. So now that we know the direction of motion without any friction, we now need to figure out if the force of friction is greater than 65, because if the force of friction is greater than 65, then the blocks aren't even going to move at all. So earlier, when we did mg cosine 35 degrees, we essentially found the normal force. And we know the force of friction is mu times the normal force. So we're given mu, 0.2, so we're going to do 0.2 times our normal force, which we found, which is 240.83 newtons. And now when we multiply these two values, we get a frictional force that is roughly 48.166 newtons. So we know that the net force of movement of these two blocks is greater than the frictional force, which means in this scenario, there will be motion. The blocks will not be sitting still. Now, what is that motion? Well, if the max frictional force is 48 newtons, we're going to have to subtract that from our net force before we consider friction. And that'll give us the net force with friction. So we'll do 65 newtons minus 48.166 newtons. And we get a net force of approximately 16.834 newtons. So this is the force with both blocks being considered and with friction being considered that is essentially going to cause these blocks to accelerate, this one down the ramp and pulling this one up with it. So now we know the blocks are going to move. We know which direction they're going to move in. It's going to be down the ramp for this block and up for the second block. And we now need to know what is the acceleration of their movement. So if we go back to Newton's second law, we know F net equals ma. So this is the net force. So we know that that will be equal to mass times acceleration. However, we have to be careful because the acceleration here would be both blocks, not just one. They're both accelerating, meaning the mass that we plug into F net equals ma is going to be the combined mass of both blocks because we're treating it as a single system. So we know that F net equals ma, and F net is 16.834 newtons, and that's going to be equal to the combined mass of the blocks, so 30 kilograms plus 10 kilograms, times the acceleration. So if we divide 16.834 newtons by 40 kilograms, which is the combined mass, we get our final acceleration, which is 0.42 meters per second squared. So we've now determined that these blocks will in fact move. They will move such that this first block is sliding down the ramp and pulling the second block up with it. So they'll move in this direction. And we know that they'll move with an acceleration of 0.42 meters per second squared.